Good morning, Ananda. Today we discuss about basic properties of electric charge. Okay, going to this class we will discuss about in the previous class, that is conductors, insulators. Conductors and insulators. Okay, what is the conductor? What is the insulator? Some substances allow the electricity through the material. That means the electric charge transferred to the one body to another body. This type of metals or substances is called conductor. That means charge transformer. Charge transform to one body to another body. It is metal to metal or crystalline. It is conductor to semiconductor or insulator to conductor. That means this is transmission of the charge carriers one place to another place. This type of metals is called substance is called conductors. Like examples are human body, metals, earth. Okay, these are the etc. Okay, these are the conductors. Insulator means these type of materials does not allow the electricity one body to another body. This type of materials is called insulators. Examples are glass, plastic, rubber, wood, etc. These are the examples of insulators. Insulators do not have transmit the charge carriers. Okay, conductors transmit the electrons from one body to another body. Okay, now method of charging. The first one is charging by contact. Charging by contact, it means direct contact. When a body, one neutral body, okay, another body initially like this, it having net charged, it is a neutral body. Okay, initially after it can be contact. Contact means both will be in a touch point. That is, net charges can be transferred to another body. Both will be are the same metals. That means like this. Okay, suppose you have 6 electrons, 1 2 3 electrons in a one body, 3 electrons are in a another body. That is separation of the charge carriers in the first body. That is charging by contact. Okay, suppose if one body having charge q, another body having charge q is equal to 0, you can touching this charge can be divided into two parts. That is q by 2, q by 2. That is here q by 2 charging, q by 2 charging. Okay, that means this q can be divided into two parts by contacting two substances. Okay, this type of charging is called charging by contact. The second one is charging by induction. Charging by induction. Okay, charging by induction is nothing but without any contact, the both bodies initially one body is neutrally charged, another body is neutral body. Okay, neutral body is nothing but it having number of positive charge carriers is equal to number of negative charge carriers. Okay, that is a neutral body, that is A. Okay, this is a neutral body. Okay, we can keep the negative substance near the neutral body. It can be separate, that means polarizing can be occur, that means here negative conductor or metal can be keeping a neutral body. Okay, that means it can be negative charge particles can be attract to the positive charge carriers. Okay, another side is negative charge can be formed. Negative charges can be formed. One side is positive charge carriers can be formed. That is polarizing or polarized. The neutral body can be divided into some parts. One side is positive charge carriers, one side is negative charge carriers. Here positive means here negative charge carriers can be attracted by a positive charge carriers. Okay, this type of charging is called induction. Suppose it can be earthing, it can be absorb the earth, it can be connected to, if suppose it can be connected to the earth, this negative charge carriers can be disappear, that means it can be transferred to the earth. Earth is a large conductor. Okay, it can be ocean of electrons. Okay, next the third one is charging by friction. It is charging by friction. It is due to insulators. Okay, suppose here two bodies, that is suppose comb or plastic rod can be rubbed with silk and wool, that is charge carriers can be formed in a glass rod, that is positive charge carriers can be formed in a glass rod. The negative plastic rod we can using rubbed with silk and wool, the negative charge carriers can be formed. Okay, this type of when it is occurring rubbing, the charge carriers can be formed in a glass rod and plastic rod and wool and fun. Okay, and comb, everything insulator materials can be friction. Suppose comb, every morning we can dry hairs, you can in hairs you can put the hairs and you can keep in a paper puzzle, you can attract the that is paper strips. Okay, and also some silk, some cloths also attract to our body. That means charging by friction, it can be due to by the insulator materials. Here in rubbing, two bodies are rubbing, that is here kinetic energy transform into thermal energy. This thermal energy converted into electrical energy. This is the charge carriers can be transformed. That kinetic energy of the when a rubbing heat can be formed, that is kinetic energy converted into thermal energy. The thermal energy converted into electrical energy of the body. This type of friction is called charging by friction. Here charge Q can be transformed into in the form of masses. Masses is linked with the charge carriers. Okay, now we'll discuss what is the difference between the mass and charge carriers. Okay, now we discuss about basic properties of electric charge. Okay, these are the three types, that is properties of charges. Charge is denoted by Q, small q or capital Q, that is SI units of charge is coulombs. It is denoted by C. It is a scalar quantity. Charge is a scalar quantity. Okay, SI units is coulombs, that is denoted by charge. The properties of charge, electric charge, that is 3. The first one is additivity of charge. The total charge of the system is algebraic sum of the individual charge carriers of the system. Suppose this is a one system. It is Q1 minus 3 coulombs plus 2 coulombs minus 1 coulombs plus 4 coulombs. These are the charges inside the closed loop. Okay, what is the net charge? Net charge. Okay, that is Q is equal to summation of individual summation of the Q's. Okay, that is Q net charge is equal to Q1 Q2 plus Q3 plus Q4. Here only 4, 1 2 3 4. Okay, like this. Here 4 coulombs plus 2 coulombs minus 1 minus 3. Okay, here 4 plus 2 is 6 minus 4. 6 minus 4 is 2 coulombs. The net charge of the closed body, one body, is equal to 2 coulombs. That is okay. Another example is, suppose here one charge is minus Q minus 3Q 3 coulombs, 1 coulombs. Here 5 coulombs. Here only 3 charges. That what is the net charge at a point? Here what is the net charge of the net charge of the one body or one place? Okay, that is net charge. Q is equal to sum of the individual charge carriers. That is the summation of the individual algebraic sum of the individual charge carriers. That is Q1 plus Q2 plus Q3, 3 charge carriers. That is here 5 coulombs, 5 coulombs plus 5 plus 5. Here minus 1. Here minus 3 coulombs. Here what is on 5 minus into here minus 4. That means 5 minus 4, 1 coulomb. The net charge of the resultant charge is equal to 1 coulomb of this body. This body or loop, anyone you can choosing closed loop or any body. This is the additive properties of the charge. The net charge is the sum of the individual algebraic sum of the individual of the all charge carriers in a system or body. That is the net charge of the individual. Okay, that is a charge. Okay, that is a additive. That means here total net charge is equal to sum of the individual charges. Suppose we can taking 2 charges, that is Q1 plus Q2. Suppose 3 charges, Q1 plus Q2 plus 3 charges. Suppose 5 Q1 plus Q2 plus Q3 plus Q5 up to Q5 up to n. We can adding the number of charge carriers. That is the net charge of the body or system or loop. Okay, this is the additive properties of the charge. Okay, now always here what is the difference between charge and mass? Here charge always comes with mass. Where is the mass? That is the having charge. Okay, that is the relation between the charge and mass. Charge and mass. What is the difference? Charge always comes with mass because every mass particle having some charge, but charge not interrelated with the mass. Okay, now what is the difference? Okay, here charge depends on mass of the body or mass. Okay, here charge independent of the charge. Okay, mass is independent of the, here mass is independent of the charge. Here charge is depends on mass. Okay, that is charge always comes with mass, but not mass comes with charge. That is mass is independent of the charge. Okay, that is charge having three types or two types, mainly two types. That is positive charge, negative charge. Another one is neutral charge. Neutral is nothing but number of positive charge carriers is equal to number of negative charge carriers. Okay, that is both will two types charge carriers are positive and negative charge carriers. Okay, the mass is having always positive. Okay, that is 5 kgs, 2 kgs, not minus 1, minus 2. Okay, this is positively always positive. Okay, and also it is mass is related with the speed of the velocity. That is 1 minus v square by c square. That is according to the quantum physics small particles. That is a rest mass. m0 is the rest mass of the body. Rest mass of the body. It is mass of the body. Mass of body. It is m is the mass of the body. The rest mass of the m0 is the rest mass of the body. Okay, that means here mass is inverse proportional to 1 by v. That means mass is depends on velocity. Okay, but here charge is not independent of the velocity. Charge independent of velocity or speed. Okay, it is depends upon only mass. Okay, it is first, it is second, it is third. Okay, three properties. One is the charge depends on mass only. Mass independent of the charge carriers or charge. Okay, masses are only positive only. It is 5 kgs, 2 kgs, 3 kgs, not minus, only positive only. In the case of charge, that is having two types, minus charge, negatively charged charge carriers, positive charges, positive and negative charge carriers are there, and also neutral is also there. Neutral nothing but number of negative charges charge carriers is equal to number of positive charge carriers. That is a neutral body. That is net amount of the charge is equal to 0. Okay, this is the relation between the charge and mass. Okay, that means here charge always comes with mass, but not mass comes with charge. Okay, there is a difference between the charges and mass. Okay, now we will discuss the second properties of the charge is conserved. When bodies are charged by rubbing, there is a transfer of the electrons from the one body to another body. There is no change of new charge carriers can be created or destroyed. That means here the second charge is conserved. Charge is conserved or conservation of energy. Okay, as you wish. Conservation of energy is nothing but, okay, some body, this is one body having plus 2 coulombs, plus 3 coulombs, plus 5 coulombs, minus 1 coulomb. Okay, this can be transferred into another body. Here plus 2 coulombs, minus 3 coulombs, only 4 charge carriers. 4 charge carriers here, 1, 2, 3, 4. Okay, here 1, 2, remaining minus 1 coulombs. What is the another charge? Here 4 charge carriers, here 4 charge carriers. Okay, that is here this charge carriers can be converted into another charge carrier. This here net charge is here net charge plus 2 plus 3 plus 5 minus 1. Here the net charge of the first body, that is 2 coulombs plus 3 coulombs plus 5 coulombs minus 1 coulombs is equal to LHS. LHS is equal to RHS. That means plus 2 coulombs minus 3 coulombs plus minus 1 coulombs is equal to unknown. It is X position. What is the coulombs? That is here 3 plus 2, 5 plus 5, 10, 10 minus 1, 9 is equal to here 2 minus 3 plus minus here minus 1 is equal to plus into plus X. Okay, here 2 minus 4 plus X, that is minus 2 plus X. Here X is equal to here 9 plus 2, 9 plus 2, here X is equal to, this comes to this side plus, that means 11 coulombs. Here there is the 11 coulombs. That means here LH is equal to RHS. Okay, that body, this body, first body can be converted into second body. That means energy or charge can be conserved the charge. Okay, yeah, suppose another example also there. Here 3 coulombs, 1 coulomb minus 2 coulombs. Okay, that total here 3 plus 1, 4 minus 2 plus 2 coulombs. It is a left side. Right side I don't know what is the charge. Okay, plus 2 plus 3, it is 5. Okay, we want to get the plus 2. That's why the other charge is 5 minus 3, 2. Okay, this third charge is the minus 3 coulombs. This is the relation. Okay, that is Q1 Q2 plus Q3 is equal to Q1 dash plus Q2 dash plus Q3 dash. That means left side LHS is equal to RHS. That means this body can be converted into another body, but charge can be conserved. The net charge is equal to, both will be created or destroyed the charge, but no other charge can be created or destroyed. Only this body can be converted into another body. Again shaking, you want shaking, the 3 coulombs comes to 2 coulombs, 1 coulomb comes to 3 coulombs, this minus 2 coulombs comes to minus 3 coulombs, but the net charge can be 2 coulombs, here 2 coulombs. Here also see here, this is net charge coulombs is here how much, 2 plus 3, 5 plus 1, 2 plus 3, 5 plus 5, 10 minus 1, 9 coulombs. Okay, there is net charge of the first body. Here 11 plus 2, 11 plus 2 how much, 13 minus 3 plus 1, 4 minus 4, that means 13 minus 4, 9. 9 coulombs. Here also 9 coulombs. That means LHS is equal to RHS. That means charge of the body can be converted into another body, but total net charge of the is same, 9 coulombs here, 9 coulombs here. That means energy is conserved. Okay, the next properties of the charge is, okay, and also another example, that is atom, thorium atom, that is atomic number 20, that convert into alpha particle, alpha to alpha, He4. That is alpha is nothing but alpha particles, He alpha, that is alpha man 2 helium 4. That means here 2 helium 4. Okay, this atomic number thorium. What is the next atom? That is here 20, that means 2, remaining is 18. So this is the another atom. Okay, it can be divided into some two atoms. That is one alpha particle, remaining another atom. That is atomic number is 18. I don't know. Okay, that means here energy or charge can be conservation. Okay, that is it is a radioactive nuclear physics, radioactive properties of the matters. Okay, next the third properties of charge is quantization of charge. Quantization of charge is nothing but the total charge of the body always integral multiple of the quantity of charge. Suppose you can going to shop, suppose picture chalk one pen. This pen not it is a one fixed quantity. Okay, 1 pen, 2 pen, 3 pen, 4 pen, not to 2.5, not to 3.5, not to 0.5. It is a single piece. That means it is a integral multiple of fixed body or fixed point. Suppose 1 pen, 2 pens, 3 pens. That is a integral multiple of numbers, not 1.5, not 1.2. Okay, suppose chalk piece 1, 2, 3, 4 like this. Suppose soaps, one soap, two soaps, 3 soaps, 4 soaps like this. That means integral multiple of quantization of charge. That is fixed quantity, fixed amount of the charge. That is the quantization of the charge. Quantization is means fixed amount of the charge. Okay, that is quantization of charge is not in total amount of charge is integral multiple of charge. That is Q is equal to the quantization of net charge. That is Q is equal to plus or minus Ne. Okay, here Q is the charge on body. It is total charge. Here Q is the total charge on any body. Okay, here N is the integer. N is the integer. E is the charge on electron. Okay, that is fixed. That is electric charge. One electron is equal to 1.6 into 10 to the power of minus 19 coulombs. It is fundamental charge. It is a fundamental charge. Okay, that is here quantization of charge is equal to Q is equal to plus or minus Ne. Q is the total charge on any body. It is the total charge, total Q. N is the integer or multiple of integral. Okay, integral multiple of integral. Okay, here is the charge on any body or any charge. That is a fixed amount. That is fundamental charge. That is constant. One electron, that is 1 E is equal to 1.6 into 10 to the power of minus 19 coulombs. Okay, this is a okay, that is according to charge. It is two types. One is negative charge carriers and positive charge carriers. Okay, the charge on electron, that is having electron having negative charge carriers. Suppose the proton having charge is positive or positron. It means plus E. That is plus E or proton is nothing but positive charge is positron is also positive charge. Proton having positive charge carriers, electron having negative charge carriers. Charge carriers are two types. One is negative and one is positive. Another also neutral charge also there. The neutral is nothing but number of charge carrier. Negative number of negative is equal to number of positive. Okay, the quantization is available. It is fixed amount of masses. Okay, that is in a market you can like marker and soap etc. There is a fixed amount, that is 1 or 2. That is the quantization of the charge. Okay, suppose here the charge always exists in a integral multiple of fundamental charges. That is Q is equal to plus or minus Ne. That means 1E, 2E, 4E, 5E. Suppose even number of charge carriers can be occur. That is positive charge carriers or negative charge carriers can be occur. That is the net charge of the amount is equal to integral of the body. That means quantitation of the charge, that is fixed amount of charge carriers can be formed. Okay, suppose we can doing one problem. See here one problem. Can a charge of the plus 8 into here, can you charge of plus 8 into 10 to the power of 18 coulombs be given to a body? What is the integral of the charge? Okay, from this problem, the solution is according to formula Q is equal to plus or minus NE. This is the formula. The Q is equal to charge of the body is given, that is net charge. Q is equal to 8 into 10 to the power of minus 18 coulombs. Okay, what is the N? What is the N the multiple of integral? Okay, E is equal to given. Okay, from this equation Q is equal to 8, this is a plus 8. Okay, 8 into 10 to the power of minus 19 coulombs is equal to, okay, I don't know what is the plus or minus, okay, N into charge of the electron, that is 1.6 into 10 to the power of minus 19. Okay, we want N. N is equal to, okay, 8 into 10 to the power of minus 19 coulombs by 1.6 into 10 to the power of minus 19 coulombs. Here, okay, here minus 18. Okay, here minus 18. Okay, here 19, 18. Here minus 1 is there. Minus 1 means it is 8 into 10 by 1.6. Okay, 1.6 1 ja 1.6 5 ja. That means 5 10 ja 50 coulombs. Okay, we get the plus 50. N is equal to plus 50 coulombs. Okay, that means the quantity of the charge on a body 50 coulombs, that is net amount of charge. Okay, on a body, the integral multiple of charge can be formed, not 2.5, not 5.5, not 20.55, not 5.5. That is even integral multiple of charge carriers can be formed in a body. Okay, thank you, one and all.